Hello. So let's go through our last week 4 of June holiday homework. Okay, let's take a look. So you have a graph here, they ask you to find average speed. Oh, that's not too bad. Average speed is, you are given a speed time graph. You're supposed to find average speed. There's a few ways you can do it lah. I think maybe you can just first and foremost find the total distance. So what is total distance? Total distance is the speed times time. So if you recall, area under the graph is actually the y-axis multiplied by the x-axis, which in this case, speed times time equal to distance. So you just have to find the area under the curve, the graph. So you realize that in this case, the graph has two hearts, I guess, more or less. So they are both, okay, the one on the left is, you need to find the area. So it will be equivalent to 5 plus 15 divided by 2 times 15. So this will represent for the orange segment. And you add in the red color segment, which is in this case a triangle, which is half times base times height. Yep. Then we can calculate and use a calculator. 5 plus 15 divided by 2 times 15. Add half times 15 times 15. You get 262.5 meter. If you recall, there's a formula here that says total distance, rather average speed, is the total distance divided by time, which is in this case 262.5 divided by the 30 seconds. .75. So 8.75 meter per second is the average speed for 30 seconds. So the entire duration, the average speed is 30 seconds. But is the question asking for that? Question is only asking for the first 15 minutes, which is just essentially, you need to so the total distance is your 5 plus 15 over 2 times 15, which is 5 plus 15 divided by 2 times 15, 150 meter. Therefore, the average speed is the total distance divided by time, 10 meter per second, d. If you choose to just 5, so the initial velocity, initial speed plus final speed, so if you can alternatively, average speed is initial speed plus final speed divided by 2. You realize in that case, you also get the answer. The only issue is the average, the initial speed plus the final speed divided by 2. It works when you are dealing with 2 speed lah. If you are dealing with 3 speed, then things get a little bit more complicated. Okay, let's take a look. It says what? Constant speed. Constant speed tells me that acceleration is 0. F resultant equal ma. Therefore, if a is 0, F resultant is 0. So there is no net force. No net force, essentially. So far what we know is we are pushing it to the left for 30 Newton. So there is 30 Newton to the left. And there's friction. So then you think about it. If 30 to the left, friction to the right, and there is no net force. No net force means they will balance each other. They will cancel each other out. So the friction here is just 30 lah. Density. So if you recall, the more dense a substance is, the more it will sink. So mercury sink the most. So here ascending order means you are talking about less dense to more dense. And we see that mercury is the lowest. So mercury is the most dense, oil is the least dense, then water. So oil, water, mercury. C. Okay, structure. So read the question. They want you to find the acceleration between B and C. Sure. So we can see, so from the graph, speed between B to C, isn't it same? Isn't it is same at 50 meter per second? Hey, constant speed Constant speed means A equals 0. So answer is 0. Lol. Okay, next. Use your answer to describe the motion. So if you recall, describe the motion, there are usually two things you need to talk about. And what are the two things that you have to talk about? First thing, okay, usually they give you a speed time graph. So describing the motion question will always come out. So typically, what you should do is you need to tell me the speed plus the actual number. Because the graph is speed, so you should look at the graph and give me the actual numbers. And you should also talk about acceleration. But the good news, acceleration is not in the graph itself. You need to interpret it, which means that acceleration, no need number. That means you don't have to calculate it first. Don't have to. So this actual number here is just read graph. Nothing to panic over here. So we will say that, it travels at a constant speed of, so time to read the graph, realize that it's a constant speed of 15 meter per second with 0 acceleration. Okay, now it's supposed to find distance. So like earlier on we mentioned, distance is the area under the graph. So the area under the graph A and B. So you're actually essentially finding out the area of a triangle which is half times base times height. Half times 15 times 15, you end up with 112.5 approximate 110 meter. 2 SF. Yay. Is it possible to tell the direction of the bicycle using the speed time graph? Well, the answer is no. Because speed is a scalar which does not mention the direction. You can't tell the direction. You need something that is vector. You need vector. Yeah, that's about it. Yeah. No. Because it's a scalar. It's a scalar term that doesn't have direction. So if you just give me something that is just a number, basically, I give you numbers, you can tell me the direction. A bit don't make sense. Okay, next one will be, let's take a look. Okay. 2.1 shows a ball falling a distance of 1.1. Sure. So A, calculate the energy transferred out of the gravitational potential store as it falls. Well, first and foremost, your energy in gravitational potential store is mgh, whereas your energy in the kinetic store is half mv squared. So in this case, you're supposed to calculate the energy transferred out of your GPS, which is your mgh, which is m is the mass 0.5 kg times g, which is 10, times the height 1.1. 0.5 times 10 times 1.1, it ends up 5.5 joule. 5.5 joule to SF already. Yay. So next, B. The ball bounces and only rises. So you see the word tell you only rises means that it's a bit surprising, because so let's figure out what's happening. So what's the energy loss? It's okay. So you calculate the energy in GPS, which is your m 0.5 times 10 times 0.8. 0.5 times 10 times 0.8. You end up with 4 joule. That means by right, 5.5 joule as you drop down, you should bounce up to the same height, 5.5 joule. But in this case, only got 4 joule. So what is the energy loss then? Just minus off, lor. .5 joule. 1.5 joule. Yay! Why is energy lost during the bounce? You see, energy is not lost. It's better to say that the energy could very well be transferred to other stores, such as sound, in the form of sound energy in the sense. Could even be heat. As you bounce the ball, maybe the ball gets a bit warmer because of the friction. After you retrieve the ball, same thing, this person gonna throw the ball down from 1.1 meter, but there is an initial kinetic, there's energy in the kinetic store. So same idea. So what do we have? So okay, how do I put it? I'm gonna try and draw. Oops, I'm trying not very good. Yep. So in this case, this is your 1.1 meter, but this one has the energy in its kinetic store already. And there is also energy in your gravitational potential store, which you calculated earlier on, 5.5. So that means at the start, it has technically 14.5. So when this 14.5 hit the ground, there is assumption. The assumption is everything changes to kinetic store. It gets converted to kinetic store. That means E in kinetic store equal to 9.0 plus 5.5 equal to 14.5 joule. This is at the bottom. So everything, your energy that is originally in the gravitational potential store converts to energy transfers to energy in the kinetic store. and the original kinetic store. And we know that this is equivalent to half mv square. That's the formula for energy in the kinetic store. So 14.55 equal to half times mass. Mass is 0.5. Times v squared. So just make v the subject. 14.55 divided by times 2 divided by 0. So 14.55 times 2 divided by 0.5 square root 7.629, which is actually just 7.6 meter per second. 2 SF again. Cool. Okay, last question. Moments. Sure, let's take a look. So first thing, before you do, you can actually kind of figure out what are the forces present. So there are essentially two forces. Okay, first is your weight of the metal rod. Oh, sorry, that's 300. That's 300 gram, my mistake. So it's just 300 gram, which means the weight in this case is 300 over 1000 times 10. 3 Newton. So there is 3 Newton going down due to the mass. The safety valve has an upward force. Yes. Oh, so W equal to 300 over 1000 times 10 equal 3 Newton. 3.0 Newton, 2 SF. Yep. Okay, next one. They say it will open when the pressure hits a certain thing. Sure. So if you recall, P equal to F over surface area. So you have P, you want to find F. So F equal to PA equal to 0.003 times 2500 Pascal. 0.003 times 2500. 7.5 Newton. 2 SF. Taking moments about the hinge determine the shortest distance the weight should be placed. Well, this you're essentially talking about balance system, which means by your principle of moments, total clockwise moment total anti-clockwise moment. So, we know about the hinge. Do we know the hinge? No, we're supposed to find, right? It says taking moments to hinge. Sure. We know the force. Isn't the force 7.5? So that is anti-clockwise. Two 500. Okay, so you have your, is it 2,500? No, that's pressure. So the force is 7.5, which we have calculated earlier on. This one times the perpendicular distance, which is, do we know the perpendicular distance? You know, 20 cm, 20 over 100. Clockwise, I don't know the perpendicular distance. That's what I'm supposed to find. But the weight is 3. 7.5. So the perpendicular distance is 7.5 times 0.2 divided by 3. 0.50 meter, which is 50 cm to SF. Yep, that's about it. Any questions, please contact me. Don't worry. Alright. Okay, thank you. Bye bye.